I think we hit the inflection point where first there was a bunch of really concrete interest in voice AI, like very late last year. And then starting kind of early this year, we're seeing real production scale deployments grow. And I think there's a couple of drivers for that. One is really genuine large time savings and ROI on deploying these things for specific use cases.
Welcome back to the Deployed podcast. We're joined today by Kwin Hultman-Kramer, who's the co-founder of Daily and the co-creator and maintainer of the pipecat open source framework, which is one of the most popular frameworks for doing orchestration for voice agents. And that's what this whole conversation is about. We talk about voice AI, kind of the state of voice AI in 2025, tactics and lessons learned as Kwin's been building in this space, examples of what good voice interactions with AI look like. It's a great conversation. Kwin literally wrote the book on the topic. We'll link to it in the show notes. He has just run a really popular Maven course, which is 22 lessons deep at this point, him and his community talking about how to build voice agents, including free play. We joined the episode to talk about evals. So I'm really excited for you all to hear this. It's basically a distillation of that course in 45 minutes. You'll learn a ton. I really enjoyed the conversation. Excited for you all to hear. Thanks for tuning in. All right, welcome everybody, and welcome Kwin to Deployed. Excited to have you here today. Why don't we start with a quick intro? It'd be great to hear who you are. Tell us a bit about just what you're up to, your founder story, and why we're talking today.
Well, thank you for having me. I'm Kwin. I work on real-time audio and video and AI communications. I co-founded a company called Daily. We make global infrastructure for super low latency audio, video, and AI. And I also work on an open source project called Pipecat, which has turned into the most widely used voice agent framework today. Pipecat's open source and vendor neutral. You can use it with Daily, but lots of people use Pipecat without Daily too, which is fun. And it's fun to be part of a big, exciting, growing open source community thing.
Yeah, lots of people, including us. It's been popular with some free play customers, and we got hooked into your world. I've set up a Pipecat integration. So yeah, I think our whole team loves working with it. I know our customers do too. So nice work on the open source front. I know you just said you do two things, open source project, pretty well known, Daily, main company. Tell us a little bit more, what's the dividing line? How do they each fit together? What's unique about each one?
I mean, the high level thing is that I feel really lucky to be an engineer who gets to build tools that other engineers use. That's a fun thing. Daily is a commercial infrastructure company. So we try very hard to route packets as fast as we possibly can, as reliably as we possibly can, anywhere in the world, no matter what kind of network connection you're on. We want to make that work for you. Pipecat is a bunch of things, like many large open source projects. It's used by hobbyists, it's used by startups, it's used by some very large companies. So AWS, NVIDIA, OpenAI, Google all support and contribute to Pipecat. That means there's a huge variety of developers who have different needs. There's a big Discord channel. And you can use Pipecat for things like a customer support voice agent that you've deployed at scale on production infrastructure. And you can use Daily as a network transport underneath that. Or you can use Pipecat on a robot dog you built in your basement using a Raspberry Pi. And then you probably don't need Daily's commercial infrastructure for that and don't want to and shouldn't pay us to move those bytes around the network for you.
Yep.
But there are really great transport layers that are dependency free in Pipecat for both WebRTC and WebSockets.
Yeah, awesome. And I mean, we started working together recently. You put together this really cool voice agents course on Maven. There's been several hundred people showing up on the ones that I've joined. Voice agents are taking off. That's part of why I was excited to have you on the call today. More and more people are moving away from the text LLM paradigm to doing something interesting with voice. I think a lot of folks too in this world are new to it. You've been living in this world for a long time. You started Daily before LLMs were cool or before voice agents were cool. Maybe you could tell us a little bit more. Imagine there's people listening to the call who are I'm curious, what are you talking about with needing separate transport layer, infrastructure, all the different pieces? You did a great job in the course and people should take it. Actually, that's just a good sidebar question. Can they still take it? Can they get in? Are you going to do it again?
I don't know. It was a lot more work than I expected, so I'm not sure if we're going to do it again in exactly that form. I threw up the landing page on Maven inspired by a course I'd taken last year on fine-tuning LLMs, which a bunch of our friends took, and it became like the Woodstock of AI last year.
Yeah.
And so this year, in about February, I tried to kind of write down everything we'd learned over the last 2 years building voice agents, because we started building like talk to an LLM tooling right when GPT-4 came out. Because GPT-4 was like this moment for me where it became possible to talk to a computer a little bit the way you talk to a person. And that just wasn't possible before. We built daily to enable human to human communication, and it all of a sudden became possible to enable, with some of the same infrastructure we'd built, human to AI communication. And that felt really, really interesting from an engineering perspective, more than from a commercial perspective, especially initially. And so we've been doing this a while. So when we tried to write down everything, it actually turned into like 20,000 words, and we put that up online. And because I like books, we did a print edition. And when people started to read the voice AI guide we wrote, they started to say things like, well, let's do reading group. Let's do like a weekly reading group, or let's do, something live where we can all like trade notes, trade ideas, learn from each other, which sounded great. And I thought back to the fine tuning course that was so much fun. I was like, oh, I'll throw up a landing page on Maven, and, a few people will take it. It'll be fun. It'll be an experiment.
Totally.
I did not expect 500-ish people to sign up. And that meant that the work and the course is more than I expected. It's totally worth it. We've done 22 sessions so far. You helped us do the evals session. We've done like a bunch of special topics. We've done like core knowledge sessions. I don't think we'll do it exactly like this again, but what I would love to hear is what people would like as the next experiment. And we're going to put up all the videos from the course, online, so people can just look at them as soon as I manage to find an editor who can do a little bit of cleanup.
All right. So people will be able to find the videos, and like a good question about what else they want to see. We can make sure folks know that that's something you're curious about. I'm going to go back to like one of the things you did in the intro session. That's what like sparked me to do this little sidebar. So for folks that are listening that are not deep in the voice world yet, this infrastructure problem you're talking about, like you've done a really good job kind of taking apart the stack and being like, here are all the parts of a voice agent. Can you do like the 30 or 60-second version of like, what are the pieces and like, why are they different from what you might be used to if you're building text agents or doing AI coding?
Yeah, so let's imagine you're building like a customer support agent. You want somebody to be able to call on the phone, talk to an LLM, answer some questions, or maybe collect some information that previously you would have had to have a human answer the phone to help them with. So you need to sort of think about 4 things. You have these amazing generative AI models kind of at the bottom of the stack. So which models do you use for production voice AI today? The models all sit behind APIs. And there's a tight coupling often between the models and the APIs, but you have to think about the APIs as well. The APIs actually give you access to those models unless you're running them locally, in which case, like, you have a little more flexibility, but most people are not doing that yet today in production. On top of the APIs, you have some kind of orchestration layer. Like, how do you write the code? How do you organize your business logic and connect it to the APIs and solve like the problems that everybody solves over and over and not reinvent the wheel? That's where pipecat sits in the stack. And then at the top, you have your application code. So you're actually writing the code you care about. So what we did in the course was we sort of went through those 4 layers in the stack. Like, how do they look if you're coming into this for the first time? What do people typically use? What are the kind of best practices and gotchas? But that's sort of the stack. And I think that's what you were talking about as the way in for a lot of people who are like, what are even the moving parts here?
Totally. And like Pipecat's helping on the orchestration side of that. How do you do speech to text, pass it to an LLM, do text to speech on the other side? Daily is premium, super fast serving infrastructure for the voice packets. I think like there's a lot of folks in our world that are just sincerely interested in learning this stuff. Go check out Quin's book, go deeper there. But like for today, to keep digging in, like voice agents are getting more popular. Everybody's starting to see cool demos. The text like really found its day, or like, its moment. You're at the heart of that trend. Like, I'd love to hear more of your perspective about just like what's going on, like why this stuff's blowing up, and like what does that activity look like in like some examples or detail, like for folks that aren't close to it. What are the cool things that are happening? It'd be cool to hear some stories.
I think we hit the inflection point where first there was a bunch of really concrete interest in voice AI, like very late last year. And then starting kind of early this year, we're seeing real production scale deployments grow. And I think there's a couple of drivers for that. One is really genuine large time savings and ROI on deploying these things for specific use cases. So imagine you run a medium-sized healthcare practice in the US, just to take a place where we have a whole bunch of customers.
I've seen several of these. Yep.
You need to like do things like call people and remind them that they have an appointment coming up and ask them if they have any questions before the appointment. If you have to have a human do that, it takes up a fair amount of the bandwidth of your staff, which is, at almost all small businesses pretty stretched thin. Now you can have an LLM make that phone call, remind the person, engage in an open-ended conversation that makes sure they don't have any questions, probably answer like half or more of the typical questions people do have before a healthcare appointment,
Yep.
and push the result of that call into some structured data system where you can actually monitor it and kind of improve the performance of that system, and therefore the performance of that part of your business. I think that's a really great example of like where the customer pull is coming from. And what we really often see is our customers are startups who are like seeing a niche and they're like, this is a big deal. I can really help people in this, in this niche. And they start like in the healthcare practice case, maybe they start by answering the phone in the off hours when the staff wouldn't be there anyway. So the comparison is, I can't do this at all, or, I can try an LLM for it. And that goes so well that then you expand into maybe answering the phone when the staff is there because you can triage, 50, 60, 70, 80% of the calls. And then you expand into a brand new use case, like actually calling everybody before their appointments. In the past, you maybe like had a file on your desk that was like, here's the category of people I absolutely have to call before the appointment. But 95% of people I'm just not going to call. I can't. I don't have the bandwidth. And you put like all of that into the LLM and you see how it goes, into the LLM queue, and you see how it goes. And that's the sort of flywheel we're seeing is low hanging, experimental, add to the normal workflow, add net new use cases, iterate.
Yeah, that's a good one. I think scheduling those sorts of things, like we're seeing those too with like, restaurant reservations, like those kinds of things. I know there's been people we all work with together, like that are doing user research and like kind of human interviews. Like one of those kind of like take phone use cases, user research that would have been a human and would have taken a lot of time to do an interview. Like, are there other like big categories of use cases? Like where is this like really fitting well today? And like maybe are there frontier examples that you're seeing that could spark interesting ideas for other people?
Yeah. And then let's pull on a thread of like, because something you said made me think of, if you're a product manager, here's the two new tools you have that come together that, you should think about. So the category that you mentioned that I kind of think of, we need a better name for this. It's like answering the phones for small businesses. There's like a huge diversity of answering the phone for small business use cases that's genuinely helpful for small businesses. And now,
Why just small versus large?
So I think the large businesses fall more into the category of generalized customer support. And that ends up just having a different like shape of the touch points. But we see both. So we see answering the phones for small business and then customer support agents. And the customer support agents at the larger companies are like in two categories. One is multi-channel touch points. So you have an app, you click a button, you can either text or talk to somebody.
Yeah.
There are pieces of that workflow that are going to LLMs on both the text and the voice side. The other piece of that is call center workflows. And you and I have both been doing this long enough that I certainly think of the call center tech stack as one of those like immutable, very slow to change, kind of legacy parts of the tech industry. Not anymore. Like every part of the call center tech stack is going to get completely ripped out and replaced in the next 2 years because the value prop of these LLM driven voice experience is so big. So we see a ton of like pieces of the call center workflow going to LLMs. The frontier stuff that I think is really interesting is like it surprised all of us that it's business use cases that blew up with voice AI first, but we're starting to see the social stuff. So like I have a co-pilot I talk to all the time to help me use my computer. That's a use case a bunch of us have sort of built in pieces because it's experimentally interesting. We're now seeing people actually do that. I have a therapist / coach / advice like friend I talk to all the time. These are the classic things where you tell somebody lots of people are doing this with a computer and they just haven't seen it yet. And they're like, no, I'll never do that. And I'm 100% sure that all of us will be doing that in 3 or 4 years. We'll just think of talking to these LLMs as something that's just part of our normal life, not even our work life. And then I think video, voice plus video, like interactive real time avatars, is going to hit that same inflection point that voice just did within the next year.
What's different about that?
It feels more social. Like the earliest real time avatar use cases are also business right now. There are things like training and compliance, like interactive testing stuff. There are job interview things. And the difference, I think, from the user experience is when you add a face to it, it just feels like a different thing in a good way. But that clearly has real value in all the social gaming, non-business stuff as well. We're not quite out of the uncanny valley for the real-time video models, but we're very close. And when we are, and when they're cost effective, which we're close to as well, like the next TikTok is not going to be a bunch of pre-recorded video that you get in a super customized way in a feed. It's going to be totally interactive customization.
For better or worse, some of these social use cases are going to be wild. I don't want to miss that you said you wanted to pull on a thread a minute ago, and we kind of kept talking. Do you
Oh
remember
yeah.
what was?
So if you're like a product person and you're thinking about like how the voice AI stuff fits into your world, I think from my perspective, there are two new things here that are like huge levers. One is LLMs are really good at like open-ended conversation. You can actually have a conversation with an LLM and it will be human-like in how it like follows along, and obviously modulo its prompting, but it will be an open-ended conversation. And that's a tool. The other tool is you can prompt and scaffold LLMs to make function calls and to follow instructions pretty precisely. There's actually some tension between these two capabilities of LLMs. When you're going from prototype to production with a voice AI agent, often what you're trying to do is like have your cake and eat it too, where both of these capabilities work really well, and you're not like one works well and one doesn't. But that sort of structured data capability, like I'm having an open-ended conversation, but I say something that the LLM needs to put into a system to remember about me. Like in that healthcare appointment example, what medications am I on? You really want that to go in the system. And so those two things, the open-ended conversation and the extract structured data from unstructured data capabilities of LLMs, are like really powerful tools to add to your toolkit if you're a product person.
When you mentioned like people are trying to have their cake and eat it too, but it's not really working. I know one of the things you're referring to, like not everybody's aware of, the more you get deep into multi-turn conversation, the more tool calling falls off a cliff in terms of accuracy with current models. But are there other like, I feel like you're this interesting nexus. You see what's actually working for these teams and what's not working. Like, what are the other gotchas that, people need to think about if they're getting started on this path?
The thing you always need to kind of get right with voice is you just can't take much time to respond in the main conversation loop. People have very set expectations from talking to other humans about how fast we respond when we're having this kind of interactive conversation. That's the biggest thing that's different about voice compared to building text mode LLM stuff. So, something like pipecat, there's a bunch of best practices about just making sure that the conversation loop is as low latency as possible. And that has ramifications for how you build the whole agent. Like you have to do context management in certain ways, you have to do function calling in certain ways. So the first thing I say is don't try to reinvent the wheel on latency. Like use something where the hard low level problems are already solved and you can just sort of build on that foundation. The second thing is the LLM capabilities are so jagged. Like they will do things that you never would have thought they can do coming from an engineering background and blow you away. And then you'll write what you think is a super simple prompt. 100% the LLM is going to do this every time, and it will do it 1 out of 10 times. And so that goes into the evals and the tooling category, right? Like how do you actually know if your agent is working once you have like non-trivial amounts of real world use? But the first step there is to sort of think about it mentally as, I'm building an open-ended conversation tool. I'm also wanting it to follow my instructions and do reliable function calling. Those are the two things I want to like evaluate very loosely, both in development and in production.
Yeah. Like you talked about an example the other day that I think would bring it home for people. Like just you were frustrated with some project you're working on. I forget even the context, but you mentioned that like you give the LM some instructions, like always start with this greeting, and it like just isn't doing that reliably, even though it will do all these other things reliably.
Yeah, that's right. Different models behave a little bit differently, but especially GPT-4o does not like to be told to echo a statement exactly, but it will often do it. And so you're like, okay, how can I like restructure this prompt a little bit or restructure my idea of what I want the model to do so that it doesn't kind of get off the track of where I want it to be? And one interesting thing, you mentioned how challenging the multi-turn stuff is. There's clearly not been enough training data in the state of the art LLM training, repositories on multi-turn conversation in text or audio. And so you will see, if you do this stuff a lot, you will see patterns where when the LLM gets a little bit off track, it is statistically much more likely that that function call that you're depending on will fail 5 turns later. So like trying to build up those patterns and have good enough evaluation tools that you can sort of find those patterns and then tweak your prompts or tweak your guardrails to prevent those like 10% of bad calls, things that are killers in production, is just so important.
Well, we should, I feel like, keep going down this path while we're on it. So like a lot of people listening are building something in this space, and good chances like the minority of them have built something with voice that's serious at this point. But like I bet people are curious. Like you're mentioning evals. I know you talk a lot about like latency. There's other hidden gotchas like turn detection, like these things that people just aren't used to dealing with. But if you were to share like, you know, some of the important things for anybody getting started in this space where you're like, I just see people make this mistake over and over again, or alternatively, like, here's some really high alpha, like just do this. I'd be curious, like just hear you talk about your getting started. What should people think about if they were going to, don't be exhaustive. What's the important stuff?
Yeah. So the caveat that this stuff moves so fast that 6 months from now, I'm sure the list will be at least a little bit different. Yeah, or next week. So the things I tell people over and over, like right now in June 2025, are if you're doing something where you're edge to cloud, so a web browser or a native mobile app, use WebRTC, not WebSockets. You can't get to production with WebSockets
And what's the
because of
why
just
for folks? Yeah, for people that aren't.
yeah, the why is WebRTC is like a protocol built from the ground up for real-time streaming audio, so it maintains that low latency connection sort of at all costs. WebSockets are something a lot of us as engineers reach for whenever we're doing a long-lived network connection. The problem is WebSockets optimizes for guaranteed delivery of data and doesn't optimize for real time. So you won't see the problem there when you're testing on your own very good machine and very good network. But in production, you'll have 15% of calls that just sort of balloon in latency or have unexpected disconnects. So because people are just getting into this world, this is my talk track like 10 times a week. Use WebRTC if you're edge to cloud. WebSockets are great server to server. No issue at all with using WebSockets if you're like terminating a telephony connection with Twilio and then Twilio server to your voice agent server. Totally fine. That's WebSockets. But web browser or native app to your voice agent running in the cloud, that's WebRTC. So that's like one. The second thing, and this is a little bit delicate because I love all the work that like the OpenAI team on the real-time API and the Gemini team on the multimodal live API team are doing, but there's a lot of super exciting stuff going on with speech to speech models. Don't use those in productions yet. And I've gotten less polite about saying that because I see so many people over and over like starting with a speech to speech model and getting stuck and spending a lot of time trying to get something from demo to production. The speech to speech models are the future. Today, what you should do in production is a transcription model, a text mode LLM, and a voice generation model, because that's going to be better at function calling, better at instruction following, easier to instrument and debug, and overall much more stable. So use
I-
speech to speech models to experiment, use
yeah.
the 3 model structure for production.
That's been a pattern. Like also like when Roman Huey at OpenAI did the first real-time API demo on stage, like it's what I feel like changed my mind about voice. And I've been a heavy advanced voice mode user ever since, but to the point about like just us talking to assistants, I do it all the time. That part of the stack, like we've seen in our customer base too. It's like prototype with the real-time API and like lots of love to all these folks, but like you run into somebody's down and you need a fallback model. Like the more that you're built on around just like one infrastructure today, like the more critical path, issues you have. And if you're doing what Quinn's talking about, you go speech to text, you call to an LLM, that LLM's not available because that company's having an issue that day, you fall back to another one. Like it's easier to swap out the parts and, have more production resiliency. So we've seen especially like that part be important for production LLM use cases. So that's a good one with you on that. WebRTC, I cut you off somewhere around like maybe you have 0.3 or 4 or 17, I don't know. But like what are the other highlights on your mind?
I'll give you one more, which is a little bit more of I sort of separate these things into like 2024 and 2025 problems. The 2024 problems are the things we spent like all of 2024 getting to the 80-20 of. It's like very low latency for every part of the stack, good turn detection, which means how do you know when the LLM should respond? How do you know when the user's done talking, basically? Basic context management that's sort of reliable in the real-time context. Abstractions for function calling that work in the real-time context, because function calls don't always happen as fast as you want them to, so you need like ways of dealing with that. There's like a half a dozen of those things that like were big problems in 2024 but are largely solved in like good frameworks now. The 2025 problem that I see most often is how do I steer the LLM really well into that like perfect sweet spot for my app between open-ended conversation and reliable instruction following and function calling. And what we're seeing people do is either sort of invent themselves or start to build on top of libraries that look like state machines, or you call them multi-agent if you want to. Like, I think, whatever terminology floats your boat, but I think of it as kind of a state machine abstraction for complex voice workflows. And the idea is that if you just give the LLM one long, big, single prompt, and then you do a multi-turn conversation, your success results for getting what you want done in that conversation are going to be relatively low. Like not zero, because the LLMs are amazing, but not great. The way you can deal with that is you can map your conversation goals into like segments of a workflow or states you want the call to be in. And then you can compress, transform, summarize the multi-turn context, customize the prompt for that state, trim down the tools list, because the fewer tools you give the LLM to choose from, the more reliably it's going to do its job, and define like exits to the next state.
Yeah.
And that turns out to be super, super impactful in improving the like success rate of conversations. There's a pipecat library built on top of pipecat called pipecat flows that is started out as an experimental state machine library. Now lots of people are using it in production. This is totally something you can roll your own if you kind of know what you want your workflows to be. But basically, like compressing, summarizing, customizing, steering for the LLM is something that I think you should start thinking about earlier than I would have said last year, when we were kind of not trying to serve as many use cases and not pushing the boundaries as much.
I want to this is a fun question for everybody I talk to these days. You said state machine. I mean, maybe you call it multi-agent. It's helpful to just clarify, when you say agent, what do you mean? And I think part of the question, like I want you to follow up with, is like, what are people actually doing? Because I think, like, just to kind of answer the question a little bit myself or give you a hint where I'm going, like some people say agent and they really mean like, this is a long-lived, self-directed, like potentially loop forever until a task is done, can take an hour or more, make thousands of LLM calls, and magic happens at the end. Hard problems are solved. No one's waiting an hour on a voice agent discussion for anything to happen. So like part of what I'm curious about is like how complex are these agents, or are these more like simple workflows as defined by Anthropic in their blog post about agents, or like I'm kind of curious, like what's actually happening when you say agent? What do you mean?
I mean, I only use the term agent because it's the easiest way to sort of describe what pipecat does for you. It like makes it easier for you to build voice agents.
Like the replacement to a human agent, like in a call center. Yeah,
exactly. I mean, I used to call pipecat an orchestration framework,
yeah,
which I think is the same thing in different words. And as you're saying, like everybody means something different when they say agent. I think the sort of big tent definition of agent is just an LLM plus context plus access to tools. And so if we take this back to like the state machine abstraction, You could think of that as a multi-agent system because each of those states is exactly that. It's an LLM plus a specific treatment of the context so far in the voice conversation, plus a specific list of tools for that node. For me personally, it's not that illuminating to call that a multi-agent system. I just think of it as a state machine. But I mean, I think whatever like fits your mental model the best. The other place I see like multi-agent stuff really, really impactful in emerging voice use cases is you often want to have a core voice conversation loop and then have other stuff going on in parallel that you can't do in real time or that you don't need to do in real time. So a good example is like safety monitoring, both what a user says and what an LLM outputs. In production use cases, you need guardrails for that. And the big LLMs have good guardrails, but as you get more sophisticated in your production deployment, you probably want your own for a variety of reasons. But the safety monitoring stuff doesn't actually have to happen in real time because, a second and a half or 2 seconds latency is okay for that. You're going to be able to sort of cut the conversation off or steer it or inject content fine at that latency. Whereas the main conversation loop latency needs to be 800 milliseconds or better, ideally. So it's a good example of like a multi-agent system where you've got some LLM stuff going on in real time. You've got some LLM stuff going on with a softer, less real time requirement. And then as we're building more and more of these things, we're finding other stuff to do with that model. Like I was talking to somebody today about building a mobile app that is spatially aware. So this is not exactly it, but think about like the most accessible example of this that I found is think about an app you have on all the time while you're driving around a new city. Maybe that app is partly a conversation, like you can ask it questions, but partly it knows about GPS information and can say, oh, your friend so-and-so really loved this restaurant last time they were here. And that is impossible to do in real time in the way that a conversation loop is, because the various lookups might happen, at 2 or 5 or 10-second latency,
Yep.
but it needs to go back into the real-time conversation. So it has its sort of own agentic quality, but it has to collaborate, in this compound system you're building.
Seeing like instrumentation and UX questions in that world. It's like I can imagine clever conversation designers, get the instant conversation started while in the background the agent's looking at more data. And those are like, you're kind of getting into this space with safety, kind of second loop kind of guardrails being run. We're getting into the space of evals, and like you mentioned, like we've joined you and Hamal Hussein and folks from Coval and Weights and Biases, like all talking about evals for voice agents. A lot of people in our world are trying to figure out evals just generally. I feel like people are getting better and better at the tech side. Maybe like what's additive or beyond the normal like LLM tool calling and text eval use cases that you think are like really important for people doing voice to think about?
I mean, I don't think we should skip over the normal stuff because I think none of us have enough evals, and I totally include me in that, even for all the stuff I try hard to help customers build for production quality. Like it's just hard to build multi-turn conversation use case evals, even if you're just operating in text mode. So the low-hanging fruit might be, and you can, I'm interested in what you think of this. The low-hanging fruit might be take eval tooling, whatever it is, take free plays, kind of text-based evals, and just hook up voice to that in the most naive possible way, because something is better than nothing. And I often like push people to do that, like build something, dump it to a spreadsheet, pull it out of free play, something, just so you have some visibility into which conversations are working and which aren't. But then the next layer of voice specific stuff is things like latency per turn, which you really care about for voice. You might not even be monitoring at all in your non-voice evals, because it's a huge difference in a conversation. We were testing a preview model from one of the big labs, and they were like, well, the P50 latency is pretty good. And I was like, the P50 latency is amazing.
Yeah.
The P90 latency is
like
terrible.
Yeah.
And they were like, oh, well, yeah, we'll work on that. And I was like, no, I mean, nobody can use, in a voice context, nobody can use a model in production where the P90 is 6 seconds. So like your P50's 350 milliseconds. I love it. Your P90 is 6 seconds. Let's make sure your customers know that, because otherwise you're setting them up for failure.
We have like a quick pat ourselves in the back, but like free play latency dashboards out of the box show P50, P90, and P99. So you get that for free. And that is, I think we got to like what a lot of our customers are doing. Like they're just like, well, what do we do with voice? I don't know. We're going to start with what we know with text and like do, you know, evals on the kinds of questions that you like brought up before. Like, you know, is the model, you know, consistently starting with the greeting that we want? Like you can write an eval and catch that. You know, is the eval calling the right tools? You write an eval, or is the model calling the right tools? Write an eval and catch that. Latency makes sense. We have a lot of people that are asking us questions, scratching their own heads. Like I think instinctively feel like they want to be doing more with like the wave file and actually like paying attention to voice attributes. How do you think about that space of things today? Like what there matters, what there's a waste of time, what's performant, what's like not really solved yet? I'm just curious how you see like the voice side of evals.
I mean, I'll tell you where I think everybody is without exception, as far as I know,
Yeah.
which is our voice quality evals are largely vibes. And, you know, if you can get the text mode like evals to a place where they're very, very good for your multi-turn conversations, you're probably okay if your voice eval stuff is mostly vibes. Now, like we should continually raise the bar, and there are some things in voice land that we do need to figure out how to build better eval tools, but I don't think anybody's gotten it right yet. The things that come up all the time are, did the model correctly pronounce numbers, addresses, the things that like humans just know how to do and we forgot we know how to do it. The classic case is it reads the phone number, you know, as an actual like millions.
10-digit number. Yeah.
Yes.
Yeah.
And there's a bunch of those. And those are sort of long tail corner cases in voice generation models. And the voice generation models are getting better and better, but you know, they still have those issues. Or on the transcription side, you can try to write evals for that too, because that confuses the LLM. So things like, I had this happen just the other day. I gave one of my apps that I talk to all the time a date, and I said 2025, and and the LLM said to me, "No, you need to give me that date again. That's not a real year." And I was like, "Come on!" And you know, you can fix that a bunch of ways, including like prompting the LLM to know that it's a transcription and blah 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 blah. But like for whatever reason, my prompt was super simple in whatever app I was using, and the LLM was like, "Nope, try again." I was like, "Okay," and that's that jagged frontier, right? Like this LLM is amazing. Why did it have a problem interpreting 2025 as a year? It even had at the top of the prompt, the date is like June 15th, 2025. So it even knew the year, but it couldn't interpret the transcription.
The fun one we ran into the other day that I shared on the course was just like the model interpreting markdown feedback, you know, markdown response from the model and like just reading out hashtag and like a, you know, bolded heading.
Yeah,
So over weird stuff like that.
the fact that the models really like to output markdown is a problem in voice agents, and you have to either prompt around it or build a filter between the text output and the voice output, or both. The worst one is when it decides to do a table and it'll be like equal sign dash 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 dash. You're like, okay, I got it. I know what you're doing.
No, those are good practical examples. I know another one in this world is turn detection and interruption. Like one of the things that drives people nuts. I'm like, love it, but like just yell at advanced voice mode in my car. You know, like, wait, I wasn't done yet. Like, try again. You mentioned that was one of the problems you felt like was kind of solved in 2024. Like, tell us the secret. You
I
know,
probably shouldn't
how
have
do we
said
handle
that.
that?
Yeah, I probably shouldn't have said it exactly that way. Turn detection at the 80/20, you know, good enough for most production use cases, was, I think, solved in 2024
Yeah.
using a technique called voice activity detection. So the basic idea for the 80/20 version of turn detection is you want to segment the incoming speech into speech and non-speech segments, and then you wait for a non-speech segment of a certain length, and you decide the user is done talking. That works reasonably well. It means you have to find the balance that's appropriate for your application between delaying too long on average and interrupting people too often on average. But especially for like customer support use cases where people kind of know they're talking to a bot, it's totally fine. You usually set that sort of delay at somewhere between 400 milliseconds and a second. And then you end up with voice to voice response time somewhere between 800 milliseconds and a second and a half, roughly speaking. And that's sort of within people's conversational tolerance. And you can tweak that for things like an AI interviewer use case where you know people are going to like be under a little bit of pressure and they're going to pause longer, but they also know what the context is. Might set it as high as 2 seconds for something like that. So that's sort of the state of the art in most production deployments today. The next step, which is definitely a 2025 problem, is trying to do turn detection more like people do. And we incorporate a bunch of signal as far as we can tell. There's a bunch of like linguistic and psychoacoustic research on this. We take semantic information from the language track that we're like playing in our heads. We listen for like rising intonation or stretched out words. We interpret filler words very specifically. So if I say, I'm not done talking, so you can train a model to try to understand those cues as well. And there's several like good models now that people have worked on and released, including a completely open source, open data one that the pipecat community has worked on called the Smart Turn model. And that's starting to get used quite a lot in production because it does meaningfully improve the experience of the conversation. It makes it more human-like. One fun digression there, I think I said we could train a model to understand that stuff. We're totally anthropomorphizing these models all the time. I was at a meetup and I was showing somebody the Smart Turn model, and I described it as we're trying to make turn detection more human-like. And what I meant was very surface level. Like we just want it to feel more human-like. I wasn't meaning to say anything about like functionally, implementation-wise, how it worked. And the person really took issue with it and said, I don't think that's how humans do turn detection at all. And my response was like, cool, but like we don't know how these models work at all. He was like, how does the model work? And I was like, I don't know. It's a deep learning model. He was like, no, but like it has these various kinds of inputs. Like, how does it process them? I was like, yeah, I mean, I wrote the PyTorch code for the first version of that model. I could tell you what the Python code looks like, but nobody can tell you how the model works. We just ran a few thousand hours of audio through it. And I think that's an important thing to internalize in this new era. Like we actually, all of these things are black boxes. And the most useful mental model to have for how these things work is what was the training data? And everything else other than what was the training data is like, it's a just so story we're telling ourselves probably.
Fascinating. I could also imagine like this getting, and this is just me processing myself, but hearing you say that, like, well, you kind of want that model for B2B or like B2C customer support type use cases. I'd probably talk differently. And so does the person on the other end of the phone than if we were doing some like AI social, conversation that's more like a friend, right? Like the way that we talk is different. And yeah, it's like how does a person learn how to do turn detection effectively? Thousands of hours of conversation.
That's right. No, 100%. And when we first, so I said we would never train models because other people are going to train the models. We'll just build the low level networking and help with the orchestration stuff. But the turn detection thing was such a big pain point that
Fundamental.
yeah, we started working on the model. I mean, it started because Christmas break, I didn't have as many meetings I had to go to. And I was like, okay, I'm going to like see whether we can train a, almost working turn detection model. And that actually worked so well that it kind of took on a life of its own. And now it's its own project. But the thing that surprised me most of all working on the very first version of that model was there are lots of data sets with audio training data for speech models and voice generation models. None of those audio data sets were the right thing for turn detection. And I think it's exactly what you're talking about. Like to do a good job with turn detection, what you need is the natural behavior of people in a slightly unnatural context of like talking on the phone or talking, over some kind of network link. It's just different. Like there's a lot of YouTube. We first tried to like experimentally pull a bunch of YouTube transcripts and label them. No, not
It's
the
not
right thing.
actual. Yep. Yeah, that's good. And so like, I think maybe just to recap a little bit, if I'm interpreting the last 20 minutes of conversation, again, June 2025, but when it gets to the kinds of nuances like this, like there's some point solutions, the open source model you referred to, like plug that into pipecat for turn detection. But what you're going to end up doing when it gets to like evals for the voice part is, you call it vibes. Like I will call it some version of dog food it, chat with it a bit. If you have the legal rights to do so, listen to some recordings. This is what we're seeing teams do over and over again in practice. Is like, I don't know, I'm going to get it to where like I feel like the voice is okay, and it seems natural enough when I talk to it, and I don't really know how to optimize it further at that point. So at some point, I'm just going to move on, right? And there's like relatively diminishing returns for most teams in tweaking that, and then like really get your text evals right, because like those are, you're flying blind without them, and they're easier to automate. There's good tools for those. Of course, we like to help, but like there's good tools for those generally. And like that cocktail of like get it good enough on the voice side, lean on your evals on the transcript side, like is kind of the normative behavior for people building voice agents today.
Yeah, 100%. I totally agree with that. The only thing I'd add is I think you see enough diversity of like success cases here that your customers probably should be like, well, which voice model should I use? And like listen to your recommendation as the starting point for that, like experiment with it a lot and get the intuition about the vibes.
Wrapping things up, maybe like two other questions for you, high level for people who want to go deeper. One, like I mentioned ChatGPT, advanced voice mode, anybody can go try it. Are there like two or three other good examples of like, this is a cool voice AI application that people could go try today that you would point to and be like, go learn from that? It's a good implementation.
Well, I'll say a couple things. One is I think you are often now talking to an LLM when you call a customer support line. And so one of the fun games is to try to figure out when that's the case. If you pay attention to it, you'll notice it's happening even when it's not necessarily announced at the beginning of the call. And people have different like opinions about whether you should tell somebody they're talking to a bot or not. One of the funny things we see is that even our customers who always say, you're talking to an AI agent, blah, 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 and then go on with the call. Often people just kind of don't really pay attention to that and they don't know they're talking to an AI agent. And if you listen to the recordings, it's very clear that people are like happy to talk to what they think is a human, even when it's not a human, which is a certain kind of tipping point. And like we passed the Turing test with this stuff and we kind of didn't even really stop stop to celebrate it. I tend to talk a lot to developers, so I think there are a bunch of examples in the pipecat open source repo that are good examples if you're an engineer trying to like look at this stuff. Because there are so many different ways to build. And so just look at the examples folder in the pipecat source repo. People go to the docs and the docs are good, but I think actually looking at the GitHub repo is great. And you can run these things locally. You can really experiment. I will also say, I think it's worth looking at the video stuff. I'll point at the company we both have worked with, Tavis, which I think has done a really good job kind of making the video real-time avatar experience very accessible. You can play with the demo on their site. You can just go into their dashboard and build your own video avatar demo, because like staying ahead and seeing what's coming is, I know, a theme for the folks who listen to this podcast.
TAVUS for people that are listening and don't know it. Cool. Well, any like, final parting advice, if you could leave people with just like one more thing or the most important thing as they get into building in this space?
Go build this stuff. It's super, super fun. And there's a huge variety of things you can build, from the very commercial to like, I'm going to run all the local models on my Mac and I'm going to like experiment with what it's going to be like when we have 10x as much compute. But there's sort of no shortage of stuff. And I really think that voice is the common denominator channel for the UI. We're all figuring out how to build around Gen AI. So like you can right now help invent the UI that will define this platform shift we're living through the early days of, because it's going to be voice if you start hacking on this stuff now.
Awesome. that's a good thing to lead with. Kwin, thanks for spending the time. Thanks for sharing the advice. I feel like there's a lot of good intel and 45 minutes of conversation for folks that are just ramping up. So really appreciate it. Have a good day.
Thank you so much for having me. It's always really great to talk to you. I'm glad we recorded this one.
Awesome. See you soon.
All right. That's all we have for today's episode of Deployed, the AI Product Podcast. I'm Ian Cairns, CEO and co-founder of FreePlay. I hope you enjoyed listening. And if you did, we'd love to hear about it. Your reviews mean a lot. They help other listeners. So give us a like, share, subscribe, wherever you're listening to this. And if something stood out to you in the episode, or if you've got feedback or ideas for a future episode, or if you simply just want to learn more we're up to at FreePlay, shoot me a note. I'm Ian at freeplay.ai. You can also find me on Twitter @Cairns. Thanks so much for listening.